Welcome to Brain Vision.
Okay, this is a passage problem, 5.118. We have if you look earlier in the question, we are told that there are these special kinds of shoes made for bouldering and rock climbing. And they're designed to have a lot of friction between the foot and the surface of the ground. So a typical shoe like this might have a coefficient of static friction of 1.2 and a kinetic friction coefficient of 0.9. So this question, 5.118, tells us that a person wearing these shoes stands on a smooth horizontal rock. She pushes against the ground to begin running, and we want to figure out the maximum horizontal acceleration she can have without slipping. So without slipping tells us right away that we want to be looking at static friction. So when we want to find the maximum acceleration she can have, we want to find the maximum, we want to be thinking about the maximum static frictional force. So the maximum static frictional force is always going to be the coefficient of static friction times the normal force, and the magnitude of the normal force will be the mass times g, the mass of the person in this case, times g, 9.8 meters per second squared. So if we want to find the maximum acceleration, then that means that the force that we can apply is going to be equal to this frictional force, and that's going to be the mass times acceleration. So this is basically saying that the force that the runner can apply, if it's equal to the maximum amount of friction, that means that she will be able to push off without slipping. If she applies any more force than this, then that'll turn into kinetic friction, which means that her foot is going to start to slip. So we want to set up this equation here. So if we have m times a here, we can just plug in our values for the friction force here. Conveniently, the m term is going to cancel, which is good because we don't know the mass of the person here. And we're told that a typical coefficient of static friction here is 1.2. If we plug 1.2 in here, then this gives us that the maximum acceleration would be 1.2 times g, and this is option D.